Hi, and welcome back to this series of tutorial. This is class 16, and in this class we are going to deal with retakes and changes. So let's imagine the supervisor gave you some retakes to do. Let's see how you can address them and quickly deliver a new proposition for the next dailies. So the retakes that have been asked by the supervisor are the following. The first one is the fact that the emission range is too wide. Okay, here at the moment of the impact, we have all the fence, all the fragments from the fence emitting dust, and we don't want that. We want something a bit closer to the middle of the fence where the truck is actually hitting the rocks. Okay. The next one is we don't really feel the energy of the impact. There's some delay in the image here, and you see that the smoke takes some time to actually rise and evolve. So we need to address that. We need to feel more the impact with the truck. And lastly, if we could add some wind, okay, going from screen left to screen right, and also maybe a bit of dissipation and diffusion, that would be great. So the first thing I'm going to work on is the emission here. I'm going to reduce the emission to something which is closer to the impact from the truck. Now, I cannot really do that on the wall emitter here, because if I change the emission to something which is at the center here and have only this fragment emitting, then I won't have the emission from the other fragments when they are falling. Okay? So this is something I have to do inside the helper emitter. And so here I'm going to add some other element to help me narrow down this emission to the center. And to do that, I'm going to lay down a sphere, okay? And the sphere, when it's a primitive, it only has one point at the center, okay? So if we look at it, this is what we have. All right. So what I would like to do is first place this sphere at the center of the wall simulation, which is here. So I'm going to down a null, okay. And here I'm going to use the bbox preset. Come on, it's happening. Copy parameter, and I'm going to paste the value here. All right, so now my sphere should be at the center of the fragments. Good. And I'm going to use that now to do an attribute transfer onto the fragment. So here, attribute transfer. And I'm going to transfer some mask attribute. So I need to create an attribute here. Okay. So I'm going to call mask init. And I'm going to init this mask to a value of 0, which is a floating value. That's good. So I'm going to transfer from the sphere some value, and I need to create the value as well here. Mask init here is going to be 1. And if I do the attribute transfer now, remove this, do a mask, and then visualize this mask attribute. Okay, so now we have everything which is transferred, and I need to okay, now we have the mask which is transferred, and I want to reduce the transfer, the distance here to something like this. Okay, maybe it's a little too small. That's too big. Okay, let's go in between, and then we'll adjust this. Okay, so this is the idea here. I'm going to use a mask, and obviously I'm going to use this mask to multiply the velocity we have here and the density which I'm going to create. Okay, so this is the few changes that I added to this setup. So let's review them. The first one here is the mask. Okay, so this is the one we just created. I just added some colors to see that they are related together. Okay, here I'm applying the mask to the velocity and to the density. Just to be a little bit ahead of myself, I also rasterize the density attribute, which I'm going to create. And then here, so we have here the density creation, randomize, and noise, okay? The same as we did on the other setups. So that's all good. Now, why did I change the points that I had? Okay, remember before I had only this, it was frozen at the first frame, and I was using this to emit the velocity. Sorry. The reason I did that is I wanted to have the velocity here, okay, changing, and actually if I visualize them now with the mask, I wanted the velocities to be changing with the movement of the fragment, with the animation. So now when it's moving, it's actually going to fall a little bit. And when it goes out of the mask, then there's no more velocity. But at least for this little brief moment, I have something which is going with the flow, with the animation. Okay, so that's why I used the previous setup here. Okay, remember this one with the attribute interpolate. Okay. Also, because of the density, I needed for the randomize, I needed the name attribute, so I kept it. And here in the attribute delete, before cleaning it, I added this as well. Okay, so this is the setup. Let's visualize the density here. Density. Okay, and let me hide this. This is what we have. And you see that the density is going to disappear when it falls out of the mask. And so now go to your help parameter here, add the density emission, obviously we need it. And then I just deactivated these guys here so I can see that it's working properly. Good. And now if we look here, we only have emission at the center of the fragments. And the next thing I want to work on is the wall emitter, because obviously when you add this back to the simulation, then you have the emission for the entire block of fragments. So go here to the wall emitter, and what we are going to do is we are going to change the speed or some of the other attributes to delay the emission to a tiny bit later, so that we still have the fragments emitting when they're falling, but only the L parameter at the moment of the impact. And so inside the wall emitter, visualize the density and disable the other, like the randomize, the noise, the phasing ratio, and the attribute wrangle. I choose to work on the speed because I noticed that the fragments here are really starting moving a bit later than the one at the center. So I'm hoping this will help me. I could have played with the age, but I prefer to keep the age starting at the beginning of my impact. Okay, right at the impact. So I'm going to work on the speed. And to be able to work on the speed now, I would like to add another parameter here inside the attribute wrangle, because if you notice here, the speed is starting, the fit starts from 0 and goes all the way to threshold. All right. So immediately after they start moving, when we have 0 0.1, 0 0.2, then it gets some value. The emit starts to be above 0, and so we have some value into the emission. And I want to avoid that. I want to only emit when we start having a certain speed. So I'm going to create a new parameter here. And to do that, I need to add here, so threshold is going to be a vector 2 now. Okay, and instead of CHF, we are going to use CHU. Here, delete all spare parameters and create the new ones. Now you have threshold. Oh, I don't remember the threshold. Okay, it was 3. Okay, so here we have 3 now. The threshold here now is obviously here Y, and sorry, here it's X. All right, so now it's the same as before. We have 0 and then we have 3 here. But here maybe I can put 1, okay, and you see that these guys here on the side are not emitting anymore. So if I move, then I have something which is progressively appearing. Okay, I have some randomized somewhere. I'm going to fix that. Okay, so I did some tests and I changed the values to this threshold. All right, so turned out it wasn't really a noise or a random, it was just the fragments activating or not, and it was not smooth enough because we had something between 1 and 3 or 2 and 3, I can't remember. All right, so now we have this. If I compare with the initial geometry here, we see that only the fragments at the center are emitting, and then this one are starting emitting a bit later. Okay, so I changed a few more things here. I added some sticky notes so that you can have this in the scene. And now if we check the emission, obviously I cached in between also. Now if we check the emission, then we see that at the moment of the impact, we have only the center emitting, and then progressively the other fragments are emitting when they are falling. Okay, so now I'm going to work on the other part of the comment, which was that the impact was a bit loose, okay? We don't really feel the energy of the impact at the moment the truck is hitting the fence, okay? So we have a bit of a delay here, and we see that the smoke is emitted, but it moves a bit later after the impact. So intuitively, the first thing I wanted to do is go here inside the simulation and increase the emission, the velocity emission from the truck and or the helper emitter. The truck was already pretty high, so I went to the helper emitter and tried to match the same amount of velocity that we have. And instead of 10, I decided to go with 60 here. So I animated the emission, and instead of starting at 10, I started at 60. And now if I look at the simulation we have, we still have the same problem, okay? If we compare both of them, if I go here with the sequencer, now we see that it's basically, it's going further, but it's starting roughly at the same frame, okay? We have pretty much the same here. So it's going further, and it gives the feeling it's starting a bit better, but we still have a bit of a delay here inside the emission. And so to understand what's happening, let's go to the smoke object here and visualize the velocity. So on the visualization tab, activate velocity, and go here in case we need to tweak some parameters. And so if I go frame by frame, so I see here the first frame, I have the truck coming in and adding some velocity, but the emission of the smoke is already here, okay? So the velocity is late, it's behind the smoke. And by the time it gets to the smoke, okay, we already have a few frames that have passed. Let's look at the velocity here on the other plane, and you can see it's really the same, okay? So it takes some time to actually come in. If I remove the truck emission here, and I just visualize the helper emitter, then let's simulate again. Then we see we have some velocity already, but it's not built enough. Okay, it's not already there inside the simulation to actually move and advect the density with it. So what we need to do is inject this velocity a few frames before the density emission, so that when the density is emitted, it's already moving, advected by the velocity. And so to be able to inject some velocities before the moment of the impact, I actually need to start my simulation before. Okay, so you go to the dot network here, and we are going to change the start frame. Now, how much frame do I need to offset the simulation? Let's go and look at the flipbook and go to frame 31 here. This is the moment of the impact. We are going to look at the frame we would like on frame 31, which for me would be something, not this one, this one. Okay, so at the moment of the impact, I would like 34, 35. Okay, and so that's 1, 2, 3, 4 frames. And so I'm going to add here 4 frames pre-roll, and I'm going to put 27. So now my simulation is starting at frame 27. Obviously, some of my emitters are going to emit density before I need it, which is frame 31. The impact is around here, okay? And I already have some density. So I need to review my emitters and tweak that. So first, I'm going to deactivate the one I'm not investigating, and I'm going to work on the wall emitter first. Here, we could obviously keyframe the scale of the density, okay? Might be the easiest. But we don't really need the velocity as well before the impact. Remember, this is the wall emitter we are talking about. And the wall emitter here is only emitting velocity when the fragments are falling. So really, we could go here and set some keyframe actually do some expression, sorry, instead of a keyframe, and say I want the emission to start on frame 31. Okay, so let's check that. Okay, so before frame 31 is 0, at frame 31 it's 1. And actually I want to check here, because zoom in here, and you see that the fragments are really moving at frame 32. So what I'm going to do here is either do frame 32, or you can do this, 31. Okay, and now let's check the value is actually correct. So frame 30 is 0, frame 31 is 0, and then frame 32 it's 1. Good. Now let's check the emission, and you see that we only have density at frame 32. Now the other one that is emitting some density is the helper emitter. Here we have the density, and so let's hide this and come here. Sorry, disable, not hide. Come here, enable the helper emitter, and do the same with it. We see that we have density before, so I'm going to do here some keyframing, and I'm going to do it here because I do want the velocity to be injected before. All right, so here I'm going to do either a keyframe. I might go for an expression as well, so I'm going to do it's above frame 31. Okay, so here I'm keeping this one so I can change the amplitude and say maybe 10 times this, and so the scale would be dependent on the so you see we go from 0 to 10 dependent on the frame. So I tweaked my emitters. Okay, inside the debris emitter here I use the same trick for the density because I want the velocity before. Okay, just to add some more variations. I didn't touch anything for the track because I want the velocity from the track before the emissions, so I'm going to leave it. And here, the wall emitter, we did it together. The wall noise, I don't touch it either because I want the velocity also before the density emission. And so if we look at the result, this is what we have. We see that at the moment of the impact, we have a much better feeling of what's happening, okay? And if we look frame by frame at frame 32 compared to before, this is what we have now, and this is what we used to have. So we have the density which is already moving, okay? And if we go one frame further, we have this movement now instead of this before. Now, I didn't talk about this before because there was not really a need for that. But because now we are injecting a lot of energy with the truck and the helper emitter, okay, because we have high velocities there, this is a good time to talk about substeps. You can change the substeps on two different locations. The first one here, the most obvious, is the substeps on the simulation network, okay? And the second one is here on the solver itself. If you go to Advanced and you go here, you have the substeps that you can tweak here, okay? Now, the first one here, the one on the simulation network, is what we could say forced substeps. It means that whatever happens, okay, inside the simulation, whether it needed or not, it's going to do some substeps. So if I do 10 here, now my simulation is going to run with 10 substeps, whether it needs it or not. But if I do it here on the solver, it's going to use some clever algorithm in there to predict whether it needs some substeps or not. Okay? And for that, it's going to use the CFL condition. So I created this file to explain how the CFL condition is working. This grid here represents the simulation grid. We obviously have voxels. Inside this voxel, we have some density and velocity. In normal condition, without any substeps or CFL substeps, the advection would take this density and move it to the tip of this velocity arrow, okay? And it would move it here inside this voxel. Now, if we add some CFL condition, it's going to look at the value of this CFL condition, here 1, and it's going to say, okay, I cannot move any value from the grid more than 1 voxel before breaking into substeps, okay? So here we are actually moving 3 voxels, so it's going to say I need substeps. How much? It's going to go back here and look at the min substep and max substep. If it's 1 and 1, then it's going to say, okay, I cannot do more than 1 substep, so I cannot do anything. I will move, like before, my density to this voxel. But if you come here and you say 2 substeps, okay, it's going to come and say, okay, I can do 2 substeps, so I'm going to break my frame into 2 substeps. And I'm going to divide my velocity in 2, and I'm going to use the first half of the velocity to move this density to this voxel, actually here. So it's going to be half across those 2 voxels. And then it's going to sample the velocity again here and move it with half the velocity to do the next iteration, the next substep. If we change this to 3, well, it's going to be the same. It can do 3 substeps. So it's going to break the velocity into 3, 1, 2, 3, and it's going to move the density here and then resample the velocities here. In our case, we don't have any more velocity, so it's going to use this one, move it here, and then it's going to use the other half, the other third of the velocity, and then move the density here. Now, obviously, the CFL condition is really sensitive to the resolution. Let's imagine we have a CFL condition of 4. In the previous case here, with this division size, the density would be allowed to travel 4 voxels before we break into substeps. And here this is the case. We are only traveling 3 voxels. With the new division size here, the CFL condition would not be respected, and then we would have some substeps. So this is something to keep in mind when you are increasing the resolution, because the CFL condition would kick in sooner, and then you would have more substeps sooner than before. Now, back to our simulation. What I'm going to do here for the substeps is I want a lot of substeps for the beginning of the simulation because it's going really fast. Okay, so I want to sample my velocity more often. And then when it's getting more quiet, okay, and it's slowing down, I want to actually reduce the substep to the minimum so that we have the maximum computation here at the beginning, and then we are iterating faster and we go faster through the timeline. Okay, so what I'm going to do is I'm going to set my substep at 4 here, okay, with a keyframe, and then, so let's say 36, 37 here. I'm going to go down all the way to 1. All right, and I want the animation because by default the animation is like this. I want a square animation, okay? So it's going to be 4 and then 2 at frame 37. So I made 2 flipbooks, okay? The first one with a max substep of 1, no keyframe, nothing, okay? This is the one. And then I made this one with a keyframe, like I said, with 4 and 2 then. And so we can see at the moment of the impact that we have some quite big difference here, okay? So it's changing, it's sampling the velocity differently, and we have a different result here. So now it's about tuning here the values and finding the proper substeps depending on obviously the velocity you are injecting into your simulation and the resolution, of course, of the simulation. Now, there's one last thing I would like to work on to improve this moment. You see here the density is going really far from the impact. So I could reduce the velocity and the density would not be affected that far. The problem is we would lose all the energy that we were trying to inject here at the moment of the impact. So what I need to do is to keep this velocity, but then lose it, dampen it after the moment of the impact. And to reduce the velocities after the impact, there's one microsolver that I can use, is a gas damp. Okay, this gas damp here is going into the velocity update also because it's going to affect the velocities. So I'm going to use a merge, and I'm going to plug the gas disturb in there, and then this one as well. And then I'm going to put them all together here. All right. Now, what I'm going to do is I'm going to leave the gas damp with its default values. I'm going to do a flipbook, and then we'll see how to tweak it. And so this is what we have with the default values on the gas damp. With just a scale of 0.1, we can see that at the end of the simulation here, the dust is almost stopping, okay? And we are losing all the interesting movement that makes the dust evolving. And obviously we don't want that. So I need to find a way to slow down the high velocities, but keep the low velocities to get the nice movement and vortex that we get into the simulation. And obviously for that, I'm going to use a mask. Here on the gas dump, you can use a mask field. So I'm going to do the same way as I did for the gas disturb, is I'm going to create my own mask, okay, by using the velocity and visualizing the velocity values. Okay, so I cleaned up a bit the file here, renamed the previous mask disturb nodes, and here I keep it there disabled so I can see the influence only on the damp, and then I will plug it back in. So I did the same thing as before. I just created a scalar field here, which I called mask damp. Okay, I created a visualization node here, and then I set the mask according to the speed, so the length of the velocity. And I choose my range here by visualizing on the smoke object the velocity here, okay, and playing obviously with the range, visualization range here. And finally, inside the damp node here, I use the mask dump, obviously. I say use the field, the mask field with an influence of 1. So use it as a 100%. I don't want the default value, which was 70%, okay? I set a scale of 0.3, and here the correction radius, I changed it to 0.02. The correction radius, if you look at the documentation, is basically here to remove the artifacts. And it does that by blurring the velocities together to avoid some weird change in directions and burst inside the simulation. The problem is if it blurs the velocity, then I'm losing all the details. So I try to reduce as much as possible this value so that it doesn't kill all the details I have into my simulation. Then target speed, set it to 0, okay? I have problems if I have it higher than 0, so remove it, just set it to 0. And then I change the field influence so that the mask here is actually damping the simulation when it's 1, and it's not doing anything when it's close to 0. Okay, and because the mask is using the high velocities, okay, high velocities we have 1, low velocities we have 0, then the damp is going to not do anything on the low velocities and damp really the high velocities. So let's just have a look at the mask for the damp, okay, just activate the guide geometry here and press play, and this is what we have. Okay, so really only the high velocities, and then it disappears. All right. Now, obviously, I could maybe tweak it a little more to actually remove the emission from the fragments from being dumped, but I will tweak that later. And so this is the result we have with the dump and the mask. Okay, so we can compare it to the one without any dump at all, and this was really going too far. The second one is the dump by default, so without any mask. And this is the third one with the mask dumping only the high velocities. And there's one last thing you can do to improve this impact moment to get a better feeling of the energy is to activate the motion blur here. Okay, if you activate the motion blur here on the ROP, you have to go also on the dust geometry here and activate the geometry velocity blur. Okay, choose velocity blur because we have a velocity field and this is the one that we are going to use. And then you can, so once you activate it, you can play with the shutter time here to add some more blending into the frame. So I made a few wedges for you. The first here is the reference one without any motion blur. And then I activated the motion blur and I went to play with the shutter time, on the camera, on the sampling tab of the camera. I used the default value of 0.5, and then every time I was making a new render, I multiplied this value by 2. So we have 1 here, 2, 4, and 8. Now, obviously, the more you increase the motion blur, the more you will need samples on your Mantra ROP. I did not increase anything here. Now, let's look at this in motion. This is without motion blur. And you can see we have a little bit of popping here. We see that the smoke is actually coming in, but popping. inside the compositing. Now, when you add motion blur, the more you add it, the less you will have this popping effect. Okay, and it's actually helping blending in the impact into the motion. The problem is if you go too far, then it's actually counterproductive. Look at this one. On motion blur 4, shutter time 4, we have something popping too far here and then back. We have some force and back. And it's even more obvious here with 8. Okay? So you have to be careful when you use this and tune it correctly to have a correct render. Now there's something else we need to check. It's the rest of the simulation, the rest of the render. When we render without motion blur, this is what we have, and then we start adding it, we will have tiny differences at the beginning, okay? But then when we start adding a shutter time of 2, then we start having huge difference, okay? Well, quite big actually. And this, if you're not really careful, it's going to kill all the details that we put into the simulation. Of course, here I have a division size of 0.1, so we don't have much details. But if you have like a higher resolution, so lower division size, you will see that the details are actually decreasing, okay? So one thing you can do, if you still want to have motion blur at the moment of the impact, but then you want to have a crisp render, or at least as crisp as possible without blurring with the motion, you can actually keyframe the shutter time. So you could have a shutter time of 2, for instance, for about 1 or 2 frames, maybe 4, and then you decrease it all the way down to 0.5 or even 0. All right, so maybe it's time for a break now, and I will cut this class right now, and I will do the other half, the rest of the retakes in class 17. See you soon.